Explorer-1, NASA's farthest-traveling rocket, proceeds with its astonishing endeavor through space, impeccably transmitting huge data from the most profound regions of the universe. For almost 50 years, this remarkable space probe has revolutionized our understanding of space. However, the probe has been sending back alarming data to Earth, leaving the entire space industry in shock. Are these disturbing signals the result of a technical malfunction or the activities of extraterrestrials? Join us as we uncover the truth behind these mysterious transmissions. Since the dawn of humanity, researchers have been fascinated by the secrets that lie beyond our sublime boundaries. This curiosity led to the historic launch of the Voyager 1 and Voyager 2 spacecrafts, among other incredible space missions. These groundbreaking missions, which have been planned for a long time, began with the launch of Voyager 2 from NASA's Kennedy Space Center on August 21, 1977. 14 days later, on September 5th of the same year, Voyager 1 followed suit. These twin probes, each weighing a significant 720 kilograms, equivalent to a small car, were launched into space during a rare alignment of the outer planets. Throughout their stunning odyssey, these intrepid explorers navigated various paths and speeds, leading to a pivotal moment on December 15, 1977, when Voyager 1 surpassed its identical twin due to differences in their trajectories. Since then, Voyager 1 has become a valuable asset, providing us with an abundance of data and unraveling space-related mysteries. Before we dive into Voyager 1's startling new discovery that stunned the entire space industry, let's look back at the remarkable images captured by the probe during its significant Jovian imaging mission in 1978. Voyager 1 was positioned about 265 million kilometers from Earth. From this vantage point, it sent back a staggering number of photographs. In January 1979, it embarked on an exceptional 100-hour attempt, creating an enthralling time-lapse film showcasing 10 rotations of Jupiter. A collection of 3,750 images allowed us to observe Jupiter's majestic dance in vivid detail. In the following months, Voyager 1 traversed the Jovian moon system, making a striking discovery: the presence of a faint ring around Jupiter and 2 new moons, which further expanded our understanding of Jupiter's fascinating space. To ensure safe passage and prevent a potential collision with Titan, one of Saturn's moons, corrective maneuvers were executed. Voyager 1 continued its celestial journey around Saturn, uncovering 4 additional moons: Mimas, Enceladus, Tethys, and Rhea. With the conclusion of the Saturn mission, scientists decided to end the planetary mission for both Voyager 1 and Voyager 2, pushing them beyond the boundaries of our solar system. They continued their voyage through space at an astonishing speed of 325 million kilometers per year. In January 1990, a new chapter began: the Voyager interstellar mission. During this stage, Voyager 1 captured some of the most iconic photographs in history, immortalizing the Sun and most of the planets. One individual who played a crucial role in extending the missions beyond their initial objectives was the distinguished astronomer Dr. Vasily Sands. As a member of the Voyager mission's imaging team, Dr. Sands passionately advocated for capturing one final set of images as a farewell gift to humanity. Against all odds, his unwavering determination bore fruit on February 14, 1990, when Voyager 1, situated 6 billion kilometers from the Sun, embarked on a visual journey known as the family portrait of the solar system. These breathtaking images, totaling 60, added to the spacecraft's extraordinary collection of 670 photographs during its encounter with Neptune. Voyager 2 achieved a remarkable feat by recording wind speeds exceeding 13,100 meters per second, making it the fastest wind ever recorded within our solar system. As the probe ventured within 280 miles of Neptune's blue, methane-rich atmosphere, it provided us with stunning insights into this distant celestial body. Notably, Neptune's largest moon, Triton, was revealed to be one of the coldest objects in our solar system, with surface temperatures plunging to a frigid -391 degrees Fahrenheit. Triton's peculiar features, such as nitrogen gas-spewing ice volcanoes that propelled icy particles 5 miles into its hazy atmosphere, also captivated our imagination. These incredible discoveries expanded our understanding of the vast diversity and complexity of celestial objects residing in the farthest reaches of our solar system. Don't go anywhere. The Voyager 1 spacecraft has recently made one of its most startling discoveries. But first, let's explore what it has accomplished over the last 45 years. The achievements of the Voyager twin probes have been nothing short of extraordinary. More than 4 decades ago, their initial observations of Jupiter and Saturn's moons left scientists in awe and shattered previous assumptions about these distant worlds. These moons, once thought to be dormant and heavily cratered like our own moon, turned out to be teeming with geological activity. Voyager 2, in particular, achieved several exceptional milestones during its journey. It made history in 1986 by becoming the first spacecraft to fly by Uranus. Just 3 years later, it accomplished another unprecedented feat with a flyby of Neptune. To this day, it remains the only probe to have traveled on such a path. As the Voyager probes continued their journey, NASA implemented various measures to extend their operational lifespan. Over the years, non-essential parts and heaters were deactivated to conserve energy, ensuring that these brave explorers can continue their mission well into the next decade. Their estimated mission end date is set for 2030. For the scientists and engineers who have been involved in this incredible endeavor from the very beginning, the culmination of the Voyager missions is both a moment of pride and a touch of melancholy. Their relentless dedication and passionate efforts have far exceeded their initial expectations. The abundance of information returned by the pilgrims has given significant experiences filled with various logical revelations and touched off the creative minds of endless scientists and space aficionados. Adventurer 1 and Voyager 2 were no standard space tests. They were fastidiously planned as steady stages, with a pivot rate more than 15 times slower than the hour hand of a clock. This planned choice limited visual obscuring as the shuttle caught pictures and information while traveling through the endlessness of space. Indeed, even before their experiences with the external planets, their great imaging capacities started to dumbfound researchers and the public alike. The shuttle started sending pictures of Jupiter prior to arriving at the gas giant. These early pictures showed the whirling mists and the famous Great Red Spot, pleasing crowds at NASA's Stream Impetus Lab. Anyway, it was the disclosure of dynamic volcanoes on Jupiter's moon Io that really took the spotlight. Io, slightly bigger than Earth's moon, ended up being the most volcanically dynamic body in our solar system. The shuttle's instruments recognized particular signs from Io, which were confirmed by the specific pictures they caught. Transcending volcanic crests and a surface scarred by volcanic ejections were uncovered, and one of Io's most conspicuous volcanoes erupted with a power multiple times greater than Mt. St. Helens, covering a region practically the size of France. While the shuttle's cameras were finally shut down to ration power and memory before their excursion into interstellar space, it is critical to note that the photos they caught did not include Mercury and Mars. For different reasons beside the Pilgrim 1 and Pilgrim 2 interstellar tests, NASA has likewise worked on other notable rockets like Explorer 10, Explorer 11, and New Horizons. Voyager 1 passed by Explorer 10 on February 17, 1998, marking the event when Explorer 10 became the most distant shuttle. Adventurer 1 proceeded on its lone excursion for an extra 14 years before finally entering the interstellar climate on August 25, 2012. Despite the fact that there were no other space tests in sight to observe, NASA didn't publicly report this surprising accomplishment until 2013. What methods guaranteed the success of the Voyager missions? One method stood out as especially brilliant: gravity assist maneuvers. These maneuvers played a fundamental role in propelling Voyager 1 and Voyager 2 on their brassy mission to explore the outer reaches of our planetary group. To reach these far-off objects and gather significant information, the shuttle required more than just their own drive systems. They needed a lift, and gravity assist provided just that. Imagine the two intrepid rockets, Voyager 1 and Voyager 2, embarking on their amazing journey through the local planetary gathering. Rather than depending exclusively on their engines, They participated in a celestial dance with some of our nearby planet's heavyweights. These planets formed groups that performed an incredible dance, utilizing their immense gravitational pull to slingshot themselves on their way. This technique allowed them to conserve important fuel and gain the essential speed to visit different objectives. Digging into the essentials of gravity assist, also known as gravitational slingshot, we see that the idea behind this maneuver is to transfer a portion of a planet's energy to the spacecraft as it sails by. Imagine Voyager 1 approaching Jupiter, a huge gas giant with a corresponding gravitational pull. With fastidious accuracy, Voyager 1 passed by Jupiter at the ideal point and speed. Jupiter's gravity pulled at the rocket, speeding it up to a higher velocity and providing it with a significant boost. Performing a gravity assist maneuver requires excellent precision. If Voyager 1 had approached Jupiter at the wrong angle or speed, the slingshot could have resulted in a disastrous deviation from its planned course. The level of precision required is overwhelming. However, the brilliant minds behind these missions successfully executed these gravity assists on various occasions, moving the Voyager spacecraft on an incredible journey through the local planetary group. Voyager 2, for instance, used gravity assists from Jupiter and Saturn to reach Uranus and Neptune. These celestial maneuvers were of indispensable significance in making the amazing voyage possible. The Voyager missions owe much of their success to these gravity assist maneuvers. Voyager 1 continued its journey into interstellar space, with Voyager 2 rapidly following after, all thanks to the precision of these maneuvers. The concept behind gravity assist is simple, but the execution is incredibly complex. Voyager 2's grand tour required a degree of accuracy where missing any of these slingshots could have resulted in a failed mission. However, the dedicated people behind these missions were determined and steadfast in their quest for knowledge. While gravity assist played a critical role in exploring the universe, another key factor ensured the success of the Voyager missions: the Deep Space Network, DSN. Often viewed as the interstellar telephone line that kept us connected with our daring Voyager probes as they ventured into the great unknown, the DSN, less showy than a rocket, is equally vital. The Deep Space Network is an arrangement of gigantic radio receiving antennas, strategically located around the world, including sites in California, Spain, and Australia. These colossal dishes, ranging from 26 to an incredible 70 meters in width, act as huge enhancers, facilitating communication with spacecraft traveling beyond our planet. The Voyager probes, equipped with cameras, sensors, and instruments, served as our eyes and ears in the vastness of space. To interpret the data they sent and to provide them with new instructions, a robust communication system was essential. That is where the DSN came into play. Imagine Voyager 1 on its way to the outer reaches of the solar system, transmitting a message back to Earth as a weak signal traveling at the speed of light across the endless expanse. The signal weakens by the time it reaches Earth, becoming a faint murmur. However, the enormous radio antennas of the DSN are capable of capturing that murmur. They lock onto Voyager's weak signal, processing it and transforming it into data that researchers can analyze. But the DSN doesn't just receive signals, it also sends commands. The Voyager missions are dynamic endeavors requiring scientists and engineers to adjust their operations based on the information received, divert the rocket, or change instruments. The orders are sent through the DSN, which communicates them into space to arrive at Explorer and guide it. It works as a two-way discussion among Earth and the farthest human-made objects in the universe. One noteworthy part of the DSN is its enthusiastic activity. It works eagerly 24/7, tuning in for those far-off signals. It resembles an unblinking eye on the universe, guaranteeing that we stay connected to our space tests, even when they are billions of miles away. The Voyager mission stands as a demonstration of the power of collaboration and development. While the spacecraft set out on their grand excursions, the DSN ensured they were never truly alone. It overcame the gaps between our planet and unexplored worlds, empowering us to explore the outer planets and adventure into interstellar space. Did Voyager 1 experience a breakdown, or were outsiders involved throughout? its striking 45-year journey in space. The Voyager 1 space probe has remained solid, constantly performing its mission. However, lately, specialists have noted a few irregularities in its performance that have sparked interest. Voyager 1 is currently conveying particular messages back to Earth, creating the impression that it is uncertain about its exact location. What makes this discovery significantly more bewildering is that the initial data received from Voyager 1 was immense and incredible, leaving NASA researchers perplexed. Upon examination, researchers found that the culprit behind the distorted information was the Attitude Control System, AOCS. This embedded gear is responsible for measuring, reporting, and adjusting the spacecraft's position in space. It has an antenna directed toward Earth, enabling it to send information back home. The glitch occurred when the software unexpectedly switched to sending its telemetry data through a faulty embedded computer that had been dormant for years. NASA engineers were able to address this anomaly by instructing the spacecraft to continue sending data through the correct computer. Thus, uncorrupted data from Voyager 1 is indeed reaching NASA. However, the question that remains unanswered is why the spacecraft switched to the malfunctioning computer. NASA researchers have advanced a theory that a faulty command from another onboard computer could have triggered the peculiar behavior. They still have yet to pinpoint the specific reason to get to the bottom of this mystery. Susan Dodd, the project manager for the interstellar mission, stated that they plan to conduct a thorough memory readout of the spacecraft and fully investigate its operations. This in-depth assessment aims to analyze the issue that led to the telemetry problem. It is important to note that, despite the inconsistent data transmission, the spacecraft itself appears to be functioning correctly. None of the spacecraft's fault protection systems have been triggered. Thus, Voyager 1 has not been forced into safe mode, and its signal remains strong. A possible factor contributing to this inconsistency is the harsh environment of space. Cosmic radiation and extreme temperature fluctuations can pose challenges to the operation of a spacecraft like Voyager 1. Cosmic radiation consists of high-energy particles originating from distant stars and galaxies. These particles can penetrate spacecraft structures, causing electrical disturbances, data signal bends, memory errors, and data corruption. Furthermore, temperatures in the vastness of space can drop to bone-chilling levels or soar to scorching highs, putting significant stress on the spacecraft's components. Despite the thorough testing and meticulous engineering that went into designing Voyager 1 to withstand these conditions, the harsh realities of space can still take a toll over time. Another captivating possibility that has captured the imagination of some is the idea of extraterrestrial interference. Could Voyager 1's bizarre behavior be attributed to the actions of intelligent beings from beyond our solar system? While this notion might seem more like science fiction than reality, it's not entirely outside the realm of possibility. The vastness of space and the countless exoplanets it harbors leave room for speculation about civilizations far more advanced than our own. However, before jumping to conclusions of alien intervention, researchers are diligently examining every aspect of Voyager 1's erratic behavior. Whether the spacecraft's peculiarity is due to a technical error, cosmic radiation, or something else entirely is not yet clear. But one thing is certain: the mysteries of space continue to intrigue and inspire us, driving our constant quest for knowledge and understanding of the universe.